All right, good afternoon, everyone. Thanks for being here. Today we're going to talk about Quarkus and why did we do Quarkus, what it is, what it provides to you, and how did we do it? And I hope I'll explain to you why we use this fairly superlative tagline, supersonic, subatomic Java. That's my objective. My name is Emmanuel Bernard. I work for Red Hat as a distinguished engineer. And I've been doing a lot of Hibernate stuff and generally data stuff in the Java middleware. But I've co-founded and I'm co-leading Quarkus at the moment. So what is Quarkus? It's open source. And it's a stack to write Java applications. And more specifically, those kind of applications. You can write your big, good old monolith with Quarkus. But really, as a vision for the project, this is what we focus on, and that's where we put priorities. By cloud native, I mean an orchestration platform that really takes your application and, thanks to some metadata, deploys it somewhere and maintains that deployment. So you say, hey, I want 5 deployments of that instance, and if one goes down, then please bring back a node and get going. Right? It's all handled for you. With this great feature comes a responsibility, architecturally speaking. That's why you've seen 12-factor applications where you try to externalize environment, delegate your state management to services. So you simplify the scalability pattern. So Quarkus helps with that. The second one is microservices. Microservices, first of all, compared to the monolith, there is a communication pattern difference, right? Probably event-driven or HTTP, but not falling down as soon as just one of the microservices fails. So there is work to be done here, and the framework helps with that. The second aspect of microservices to me that is really important is the density. We had one monolith, and now we're deploying many microservices. So if you have a bit of a cost as far as your deployment, it's 20x more or 50x more. Serverless is kind of microservices, just the extra step. One interesting difference is that a microservice will somewhat always be up and listening to HTTP port or something. Serverless functions, they literally stop. So you need to restart them, potentially from cold start, and you pay by the 100 milliseconds. So if you take 20 seconds to start, that's an expensive proposition for a function. Okay, it's hard to explain Quarkus, so I'd rather demo it to you. And the best way to get started is to go to the website, quarkus.io, and here you'll see a start coding, which is a code generator. So let's do io.quarkus. Is it big enough? I didn't hear, so let's make it medium bigger. Devox, something's coming. And then I'm going to write a to-do application. So I'll need the backend of a to-do application. So I need a REST, stack. So I'll use JAX-RS, RESTEasy JAX-RS. I'll use the JSON-B binding because I'll talk JSON. I'll use Hibernate Validator to validate stuff, the bin validation, one of the bin validation implementations, and Open API because I want to expose my API to other UIs, because maybe mine is not that good. And I'll persist the data, the to-do, into a database. So I'll use Hibernate ORM, but I want to do it with Panache, and we'll see what that means. It's not Panache for the French-speaking people, it's Panache. And then I'll use Postgres as the backend. And then, so you've seen quite a bit of options on data. If you were to do some messaging, we've got quite a few options there. Kafka, AMQP, and so on. Non-blocking reactive clients, we heavily rely on vert.x. I'll explain that a bit later. Where do you want to deploy it in the cloud? How do you push that? Observability, health, as well as metric and open tracing are really important. Security, of course. Integration, thanks to the good folks of Camel, they did great work in providing first-class integration support in Quarkus for all of these, and more coming. Cogito is really some secret name, but behind it is the Druce, the rule engine, BPM engine, etc., etc. Serialization, etc. Alternative languages. So I'll code in Java and using Maven, but you've got alternatives there. Okay, so let me generate the app. And let me copy it, not there. Oops. There you go. And, oops. Don't see that. Yes. Then I've got my DevOps Something's Coming project. I'll probably need an IDE to get started in my development. I'll use IntelliJ today. We've got a nice VS Code integration, Eclipse integration like as a plugin, and IntelliJ is coming as well. So that's a good thing. And the next step is to really put Quarkus in dev mode. So compile Quarkus -dev. As we'll see, it will start. Open the debugger port, non-blocking debugger port, so you're really in development mode, just so. Some people said debugger is like for the weak, but no. It starts in 1.5 seconds, which is kind of good, and it's the dev mode, so it's not necessarily the fastest. And then we're ready to get started. Let me show you what the app is doing. We've got localhost 8080. That's where we land on a sample page. You can do. There is hello, which is the endpoint that we go and address. Okay. Let me not forget something. Let's make that bigger for you. I'm not a UI guy, so I'll just copy the UI so that you don't suffer my skills. All right. So I copied it in the resource, directory. So we've got hello, and now we're ready to get coding. So let's open that up. And I got the example resource. This is the JAX-RS annotations. Who use or knows at least the JAX-RS annotation, add path? Okay, a fair bit. Who knows about the Spring Web, style, REST controller, and so on? Okay, it's about 50-50, so let's not make jealous. I'll start with Spring, and then I'll move back to JAX-RS a bit later. So here we'll see extensions, which is a fancy name for dependencies and more stuff. But in Quarkus, you also have a command line, which allows you to play with or create the project as well as add dependency, which we call extensions. Extensions equals Spring Web. So it started. You see that Quarkus just restarted. Hey, new dependency, let's restart. I didn't have to stop it, restart. And you see that the project really says, hey, you changed your POM. That's really what an extension is. It's just a reference in your POM. Okay, so let's change that piece of code. REST controller at request mapping with the hello, I guess, endpoint. Forget about that one. It's get mapping. And produces is, what is it, text/plain? Yeah, always. There you go. So we should be good and have the same result. Yes, cool. So see, it's not that big it's really almost like a one-to-one mapping. So hello, DevOps. Where is Spring? Refresh. I see the result. Refresh. Well, not only did I make a typo, but also I don't know how to write in Java. The cool thing about the Quarkus dev mode is that it shows you the problem right away. It says, it seems that you goofed somewhere. And yes, I forgot the N and Quarkus. I go and refresh, and I see the result right away. Okay? So what's the magic here? So first of all, the developer experience is really good. I test, I see the result, I move back to change my code. And the way it's done is, you see it here. You see that when you do a refresh, Quarkus will look at the files that has changed. It will recompile them. stop Quarkus, so not the JVM, but stop Quarkus, restart Quarkus, and serves your thing. All of that in 300 milliseconds. 350 milliseconds. So it really feels like instantaneous. It's, you know, for like a Node.js guy or a PHP guy is like, hey, yeah, sure, we've been doing that forever. But this is Java, so difference. Okay, what do I want to show you? Yes, this speed is actually important for this developer experience, like the live evolution, as well as tests. So hello DevOps with Spring Web and Quarkus. I can go and run this. As you can see, there is a Quarkus test annotation, which means we're going to literally start the whole Quarkus in the test and keep it around for your test suite. And you'll be able to go and execute your test with the full thing, not a mock, nothing lazy loaded. It's fully executed. Cool. But what we really want to do is a to-do application. So I've got a front end here, which you can find, I forgot the name, but you can find it online. And what we're going to do is write the backend for that. So do something. It's actually doing nothing because there is no backend. So let's go and start implementing that. To-do resource. So this is, I'm going to use JaxRS this time around. Path, sorry. Let me make it bigger for you. /API is where my frontend expects things to happen. And here I'll use JSON. So, no, hold on. Media type, this one. JSON, okay. And I don't think I'll produce. Oh, of course I will produce stuff. There you go. And then I can start creating my endpoints. And the first one is probably get the list of all of the to-dos. So let's make it a get. The path /API seems fine. Public list to-do, which is going to be my JSON representation, or Java representation of the JSON I'll exchange with front end. So let's create that JSON. Yes. Oops, to-do, yeah. So public string title. So that the field names are actually expected from the front end. So I'm just a messenger here. So title is actually the to-do, the real to-do. Then I'll create a Boolean that represents whether or not you have completed your tasks, and what's the last one? The priorities for your things that you have to do. Order. OK. So that's good. And then I need to implement something that fetch all of my to-dos. OK? So technically, you would write a DAO or a repository that will do that. You can do that. With Panache, we have something that is somewhat similar to the Spring Data JPA approach. So you can do to-do resource. To-do repository. And then you will extend Panache repository and so on. But I'll use a more opinionated way of doing things, which will make your code even, leaner, in my opinion. And then I'll explain the difference later. But here I'm going to mix in one class the entity itself and the repository. Okay, so I'll extend Panache entity. And oops, hold on. You guys need to tell me when I'm just doing something totally wrong here. Yes, so that's to-do that I want to persist, okay? Let's make it bigger, add entity, and then I'll extend the Panache entity object. And that's okay. That's an entity. It's a regular JPA entity, so I can use add not blank. I can use add column name. Order is a keyword in SQL, so that wouldn't fly. Ordering. So here I can go back, and the traditional way of doing JPA, you would add inject your entity manager, and that works. You actually can mix those two together. But here we're not going to use that mode. We're going to use the repository approach of of Panache. So return, to do, dot, and then I've got a bunch of operations to create, update, delete the entity, as well as doing a bunch of queries. So here I want to list all of them, and I want to sort them by order, which is the property. I should be good. Again, I haven't stopped my application. I test, and it fails. It fails, and it tells me, hey, maybe if you configured where is the database, maybe I can do something for you. It's like, sure. And you know when it's, you hate Java when the meaningful information about the stack is the last one. So we reverse the order, so you see it right away. I've been bugging the team for a long time, and they did it, so that's cool. Anyway, I need to configure my database. So I'll cheat a tiny bit here. I'll copy this. I'll explain to you what it is. Let's go back here. And we've simplified the configuration. We put everything into application.properties. Probably sounds familiar. While we expose APIs that you're familiar with, like Hibernate, we actually try and simplify the integration between the various frameworks. So just the fact that you've defined a data source, every extension that needs a data source will pick up there. So you don't have to redefine it and synchronize the frameworks for you. We do it as part of the extension framework. And then I added something, because I'm in dev mode, I will do a drop and create of the database schema, enable logging, and don't do that in production, but here I will deploy the application as if in production, so I'll also do a drop and create and import a file. I'll mention that a bit later. This is the environment. So you can say, hey, Quarkus, please deploy my app in this environment. Some frameworks use the dash environment name, application dash environment name. We like to have everything in one file to really avoid duplication or see everything on one file. It's really a choice. We could evolve either way anyways. Okay, so the application should work now. It does. No data. So let's go back there and copy some of the data. So I've got insert statements. I don't know if people are familiar with that, but in Hibernate, you can create a import.sql file. You can change the name, by the way. It was the property you saw rapidly. Oops. No, hold on. There you go. Then I go back and refresh, and I've got the data. Again, I didn't stop the app. I just worked, see, okay? So I could continue on the CRUD style of the operations, but here I'll do a search engine, which helps me to show you, so that I can show you the query part of Panache. So let me go back to the resource and create a search engine. So I'll create a different endpoint. I'll have a different path, of course, search / I'll pass the parameter as inside the URL in this case. Damn. Okay. And then it's going to be a list of a list of to-do. Of course, search. Then I do the mapping with my parameters. So that's the word one, string word at path param page. It's going to be an integer, and I'll call it page index. And then typically this piece of code, that's a search engine, so that's fairly complicated. I'll put it in my DAO, okay? So again, here I use the opinionated active record style pattern of Panache. So I do to-do dot, and then I'll create a search function with the word and, the page index. And what I like is that it really flows. Like I'm thinking, okay, something inside to-do dot, blah, 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 please IDE create the method for me, and I'm ready there. So the next step is to actually write the HQL query that does this search engine. So let me do a list. So it's a bit of a simple way to pass the HQL query here. Completed. False. That's it. That returns all of the to-dos that have not yet been completed. And it doesn't look like HQL or SQL, JPQL, but it is for me. And it should be for you. The key point is that this is contextualized JPQL. Select to-do from to-do where. We can infer it because we're inside to-do or the to-do repository. And then completed equals something. If you just pass the predicate, we can pass the value and you're good to go, right? Of course, and what I like about this model is that it scales in complexity. So if I say, OK, completed equals first parameter, and I'll filter by the title using the like operator, passing the second parameter, you see that just add more. So it really scales nicely. I don't have to rethink entirely my query method. So question mark, word plus question mark, OK. I actually can go all the way down to a full JPQL query. So it's the same model for everything. So select, say, to do C from, I don't know, to do T join, T dot something, that would be C, You can really go for the as complex of a query as you want. The other stuff is I wanted pagination. So I'll replace the find. Instead of returning the results right away, I'll do a find. Hold on, where am I? There you go. And I'll pass the pagination. So either you can create a page object that you can pass across your layers to propagate that information. And once you've got pagination, you can get the page count, last, first, the classical paging approach. But here, I just want to say, here I want page index of, say, a page of 3 elements each. And I'll just go on the list. And I go back there, and I'm ready, except I don't have a UI. And I'm not doing that. As I said, the cool stuff is with OpenAPI in dev mode, by default, Quarkus enabled the Swagger UI. We disable it in production. We don't want people to abuse your stuff on your own account, but you can enable it explicitly if you want to. So here you got the Swagger UI, which it was just mind-blowing for me. I didn't know that. It's probably just living under my rock. But to me, it's like I can test my stuff with a UI without having to write a UI. Awesome. So here I'm getting the first page of Quarkus, and I see 3 results. And if I go for the last page, I had, I think, 8 results. So you see only 1 here. So I've actually retained the search engine very quickly that way. Good? I'll show you one more thing on that front. I'll stop Quarkus. And of course, you can go on Maven package to then create your jar and then use Java -jar and then run Quarkus. But here we're going to use native image compilation. So it's just Maven package -p native. That's all you need to write. Okay, that's going to be important. I don't know if people have been into other GraalVM talks, but this is the line you really would need to write to do the native image compilation. Plus, this one doesn't show the metadata, so that's even worse. OK, so let's go back to the presentation while this is running. All right, why did we do Quarkus? We're seeing people moving from monolith to microservices, right? Oops. So there are 2 important things here. The first one is microservices from a density point of view, of course, is more deployments, right? So every fixed cost you have in your deployment is going to be multiplied by 20 if you have a 1-to-20 ratio. It's actually worse than that because the way you scale is, in the monolith, is usually to have a bigger process to as much as you can. In a microservices universe with an orchestration platform, the way you scale is adding a new instance somewhere in one of the clusters, somewhere in the cluster, 2, 3, 4, 5 instances. And that's how you multiply your requests per second. So if, as a request per second, you might not be the best, but requests per second multiplied by 2, 3, 4, 5, because you deploy 5 times, and you reach your numbers. Okay? So that's a very different scalability model. Function, as I said, does a cold start, so restarting is an important aspect. The other problem is a team of 20 people working on the monolith, and then you say, let's go microservices. So you got 20 microservices, and you have 20 people, right? So 20 people for one app, and then 20 people for 20 apps. So each developer has less time to spend on the framework, fixing the bugs, switching between microservices. So that's also important consequences of this microservice approach. So why do we have microservice? First of all, I do think that it's coming because we have a dynamic orchestration platforms like container platforms. I'm thinking Kubernetes, OpenShift, your cloud provider, things like that. Because we have that, deploying 1 or 20 bits is just as as simple / as complex. So you can go bananas in the splitting. The reason you do the splitting is to have agility. You say, I'm splitting things, and I'm realizing the microservice number 2 just doesn't scale. I need to move from a relational database to in-memory database. I can do that, rewriting the entire thing without affecting the rest. If I had to do that on the monolith, that's like, don't even bother, because that's too much interactions. You won't be able to do that. So you can also add new features, do A/B testing. All of that feature set is really massively simplified with the microservices approach. Then comes Java. So when we say, hey, Java, please consume 20 megs of RAM, XMX20M, right? This is 20 megs of heap. That's the one on the right side, right? But the total process, the Java process, consumes way more than that because it's got metadata around your classes, information around the JIT, the code that is actually compiled, and so on. Remember, Java has been designed to be super good in requests per second back in the end of the 90s. Who was alive? Okay. Well, not that many people, I'm scared. Yes, so they made trade-offs, and they said, request per second, great. Let's spend a bit more CPU and more memory to achieve that. That's fine. But Java is an interpreted language, so initially you interpret the bytecode and you slowly compile stuff via the just-in-time compiler so that it's really fast after a while. But of course, the startup time suffers. We've got a big JDK with lots of features. We've got lots of frameworks like Spring, Hibernate, RESTEasy, you name it. And then your app. So that's a lot of classes to initialize. And memory-wise, those classes actually take space inside the non-Java heap size of the Java process. Because you need to know what a class is a superclass of in case a new dynamic class is dynamically added, changing things. How many times do I go through this method? The just-in-time compiler needs that to do its job. So all of that takes space. For a monolith, it's okay because you essentially the heap space, the Java heap, is actually fairly bigger than the meta space. But when you go into microservices, when you don't need that much Java heap, then the ratio becomes very disadvantageous. And what we've seen is some teams are actually liking the Java ecosystem, but they are moving to other ecosystems because of the startup time, because of the memory density, and they really have to embrace this other ecosystem. Remember, one app, 20 or maybe 50 deployments. So you pay a lot. You pay 20, 50x by this quote-unquote fixed cost. So that's what Java was. And then we saw things coming, and we've been working on Quarkus. So what is Quarkus? Quarkus is 4 things. It's, first of all, developer joy. So we knew even if we invented like a magic technology that would go to the moon and back in 0.3 seconds, you guys would not use it if it wasn't really focused on making your life simpler as far as writing code and delivering, okay? So every single decision we make is always as the trade-off. Is it improving or harming the developer? I don't want to say joy, but developer focus and productivity. So the zero config, the live reload, no plugin, no nothing. It's just Quarkus listening to the file change, restarting everything, and it's so fast. The speed is critical to make it very useful and very reactive from a code change to the reality being seen. We reuse APIs that you know, but sometimes we improve them for the simple usage. For the usage that are very common and a bit boilerplate, we try to simplify that. You've seen that with Panache. There are more. Configuration is unified into this one file, and so on and so on. And the native image generation, remember that one? So it took about 2 minutes, so it takes a bit of time. But then remember the line. It's just this, right? Instead of the instead of this one. And then what you see here is that you've got a tag. Oops. The stuff in red is really a native executable. So it's not a jar. It doesn't need a VM. It is the VM plus the app in one thing. It's started. By the way, it started in, where's the numbers? There. 50 milliseconds. It went to the database, created the schema, added data, came back. That's done. All right, let's stop this one. Remove this one. Let's go back. OK. So that comes to the supersonic subatomic, mantra. Subatomic is about memory. We really work hard, and I'll explain how, but compared to comparative frameworks in the cloud-native era, we really are half the size in memory, right? Remember this RSS size? It is half the size on the same JDK. Okay, and these numbers are JDK 8 simulated a single core, which is closer to containers. When you add more cores, then the ergonomics of Netty and other stuff are consuming a tiny bit more memory. If you go to Java 11, they've been growing a bit, so it's, again, a little bit more memory, but those numbers are in the same curve. But you could say, well, it's just a REST hello world, it's not useful. First of all, I think in the cloud it's useful, but let's see an actual real REST plus CRUD application using Hibernate connecting to Postgres. You've got the same kind of optimizations. And if you go for the native image compilation, you see those like 10x compared to what we had in the past. That's the native image compilation that Grall VM is providing as part of one of the sub-projects. Supersonic is about the startup time. We work really hard to start much faster, even on OpenJDK, and that makes a big difference for a lot of teams. In tests, in live coding, et cetera, et cetera. If you really want to go serverless, it's a key aspect to really start below this 100 milliseconds, and that's what Quarkus plus Grall VM is providing to you. Ahead of time compilation, really compile the whole Java code, before you even start. So you're ready, you start, you're done, right? These are the numbers. By the way, there was time to first response, not time to start, because we want to exercise the framework, come back with the result. We also unified imperative and reactive under one common layer. So we use Netty, vert.x, and everything is built on top of it. And that's critical for IoT and a very high number of requests per second to disconnect the number of threads to the number of requests. So we see it as the future or the present, really. But we do offer the imperative style and the reactive style with similar APIs. So you make the choice depending on your needs. And finally, we do expose pretty much a lot of the APIs you already use. So you already have these 5 years of experience in Quarkus that you're, the guy wanting to hire you is asking for. It got published in this year, just for information. So 5 years is always tough. So how does Quarkus work? The key is to say, let's take the bootstrap of the framework, the startup time, and move everything at build time. As much as we can, rather, at build time. What does the framework do? It parses the XML file, like a persistence.xml or application.properties or something like that. So, XML parser, loading the file, gathering some metadata. Then it does class path scanning. Any annotation-driven framework right now does class path scanning, trying to find the @entity for Hibernate, the @inject for CDI engine, @autowired Spring is looking for that. And once we find the relevant classes, we go and analyze the class to find the getters, the setters, all of the metadata, right? And all of that build-time metadata, not build-time, but startup-time metadata, we actually look at it and create our runtime model. In the case of Hibernate, the SQL query to create the entity and so on and so on. Then we're almost ready. We prepare reflection, we create the various proxies, and then we're ready to start. So that's a lot of work to do at startup time. What if you took all of those bullet points, except the last one, and moved them at build time? That's what Quarkus is offering. Quarkus is a framework to start other frameworks at build time. So we do the work once, right? You do the work at build time once, and then when you start, you already have done most of the job, so you have less, so that's faster to start. More interestingly, because there is so much work that is done at startup time to scan the classes and all of that, it means that the bootstrap code is no longer needed because you've done it at build time. So at startup time, you have way less code that is actually loaded by the JVM. That's why you get the 2x memory performance as well as the startup time improvements. It's a very virtuous cycle, but it requires to improve everything, all of the framework, trying to move them as much as possible at build time. And of course, since we do a bit of a closed world assumption at the application level, we assume we know the application when we do the build time entirely, which means we know the @entity, we can generate the proxies that Hibernate would generate otherwise, and we go for it. So what does Quarkus does? You do compilation, then we fetch the framework, and that phase, which we call the augmentation phase, is that real-time gathering of XML and annotations and all of that. And then you've got the choice. You run for the JDK mode, or you go for the native image compilation for the extra kick. And that's what GraalVM native image is providing. They literally do all of the compilation of your application at startup time. At build time, which means, of course, everything is compiled, so it's faster. You don't need the just-in-time compiler, so it's smaller, and you don't need the just-in-time metadata, so it's even smaller. The other advantage they do, the key thing they do is they assume that at build time they know entirely the code path, so they can eliminate all of the code that is not used. Imagine the number of JDK classes you actually do not use in your application. Right? So that's a lot of eliminations you can do. That's why it's very small. There are gotchas with that. You cannot do arbitrary reflection, because if you could, you would be able to fetch any piece of code. Therefore, you would be able to load dead code elimination would be eliminating nothing. So you have to pass the list of classes you want to do metadata on. And GraalVM is... so what does Quarkus bring to GraalVM? For us, as backend developers, it really brings a massive usability boost. First of all, Quarkus, I don't know how to say that, but Quarkus, every single area we have in our ecosystem, every single framework is actually supported on GraalVM. It runs, which is a lot of work, but that's really the things we bring on the table. And then we do a lot of work for GraalVM in your name. So Hibernate knows, hey, maybe I need to do reflection on those classes, and those classes. Let me pass that information to GraalVM so that you as a user don't have to pass that information. That's a massive improvement. So no need for manually passing that metadata, using an agent to run, do a pre-run, expect that everything has been fully discovered and so on. And we help the dead code elimination by saying, hey, we know we're not using those dialects in Hibernate, so let's remove them from the code base. Let's help the dead code elimination do this. So when should I use what? Let me drink. So what should you use? You should use Quarkus. And then you've got the memory density and the good request per second per megabyte. This is our focus, requests per second per megabyte. Because when you deploy, and the way you scale is by deploying more instances, requests per second per megabyte is the value you really need to think about. So you will win with Quarkus in either environment. Fast startup, high requests per second per megabyte, etc. But if you're more leaning towards very good raw speed performance, right now your OpenJDK HotSpot is going to be better with a just-in-time compiler. Also, if you have a heap size that is somewhat significant, then they have better garbage collectors than GraalVM at this stage, right? So that's some of the trade-offs you can think about. And also, all of the monitoring and generally tooling you have around the JVM, they're there and they will be running, right? Compile once, run anywhere, have the right monitoring, all of the library will work. With GraalVM, you can go the extra kick, right? You go to 11 to number of requests per second per megabyte. This is figurative, by the way, not 11 requests per second. And if you have a reasonably okay heap size, then that's probably where you should go for that. And if you have startup needs that are really sub 100 milliseconds, go for the ahead-of-time compilation. So Quarkus is really a framework to help other frameworks start at build time. And then we have those extensions that do that work, do the bridge between, say, Hibernate and Quarkus and do that extra work. And we really think that it's not a matter of providing to GraalVM the list of classes you want to do reflection on. We really think we need to do as much work as build time to really embracing all of the potential of this AOT approach. It's not only the JVM that needs to do the job, it's the JVM and the frameworks doing most of the work before it's even started. Let me do more Quarkus things. I'll go really fast on that one. Got awesome tests. We test and we start entirely Quarkus, no laziness or anything, and then you can do add inject in your test and go running. You can do mocking. We have a way to smoke test the actual Graal VM native image. I won't go into the details, but that's a feature we have, which is useful. We use it heavily to make sure all of our ecosystem works. Remember, active record versus repository pattern. So the one on your right is probably the more traditional way you are actually writing persistence, right? So you create your entity, you create the to-do repository, extending Panache repository, you inject it, and off you go. It's your style. This is less line of code on the left. To me, it flows better, but it's your choice. Observability is critical. We use heavily Eclipse MicroProfile, which has done awesome work around that, metrics, health, and so on. Messaging is heavily covered. That's a key area of microservices. Again, via the Eclipse MicroProfile reactive messaging abstraction, where we support Kafka, AMQ, MQTT, and more. You can go straight with Kafka, and even using the Kafka Stream framework, which Kafka Stream framework plus the live reload, you do the change, you see the change of operations going on. It's just awesome to sorry, I'm not Italian. Security, I don't have time, but I encourage you to go back in time. Yesterday, there was an awesome talk by Sebastian Blow. Of course, everything is recorded at Devox, so you will see it online. And Spring, we do a different model. We look at the Spring annotations, and we map them into the engines we have inside Quarkus. Remember, we don't want to duplicate classes and duplicate runtimes, right? And we do so much work at real time, and that's a lot of work for each framework. So we look at the Spring annotations, and we convert them into the equivalent CDI or RESTEasy annotations, and we get them running. If you want to know more, Georgios tomorrow morning has a talk about that. Can you add your dependencies? Yes. If you run on the JVM, no problem. If you run with GraalVM AOT, you might have some trouble, so depending on the maturity of the dependency. But that's where the Quarkus ecosystem come to, right? We guarantee it's going to work, otherwise it's a bug, right? Plus, extensions do a lot more. They actually do a lot of work at build time. Remember the memory optimization? This is the build time work, right? We help the dead code elimination and the whole developer joy, rapid deployment. This is also massively helped by the extensions. Same for the configuration file. So developer joy, supersonic, super low memory usage, super fast startup time. Unifying imperative and reactive, and you have the choice to use which one under one, but we have one layer. And you already have a lot of experience with the APIs Quarkus expose. Quarkus actually does nothing at runtime almost. It does everything at real time, and then it exposes RESTEasy that will actually listen to your requests and do work, or vert.x or Netty, right? So this is super mature stack that is actually run at runtime. Who knows about V for Vendetta? Okay, so November 5th is an important date. It turned out, so we are November 6th, but it turns out that we did something yesterday a bit sneakily. We released Quarkus 1.0 CR1. So we're announcing Quarkus 1.0 today. We've had an awesome community feedback. We've done 42 releases since we started, so we couldn't just not do that, right? 42. And we did 30 public releases in 8 months. So that's about 8.5 days between releases. And it wasn't just bug fixes, it was always new features, and we pushed really hard. And the community really added a lot of extensions, improved extensions, added a lot of things to the platform. We have 177 contributors, so big thanks to them because they made it happen. This is, what we're saying here is that this is production ready. Red Hat uses it in their products and services. We have quite a few users using it in production. By the way, remember the OpenJDK versus GraalVM? We have about an 80-20. So 80% of people go to OpenJDK in production for the tooling and all of that, and because the benefits are already great. And 20 go to GraalVM. It really depends on their needs and if they need to go for the extra push. And as I said, it's a solid runtime based on frameworks that have years and years of experience. So we didn't reinvent the wheel. We reinvented a tiny part to really make the whole Java ecosystem better. I hope you will like it and join the revolution. I don't know if you've started using Quarkus already, but quite a few people have been doing that. And if you like us, go and star. Some people like to have a star ego, contest. So go and star us on GitHub. And I'll stop there and open up for questions. We've got a good 6 minutes to interact. Thank you very much for attending. Questions? I know I'm doing awesome presentation. There's no questions, but none. Come on. I don't see you, so please shout out. Yeah? Can you speak super loud? Okay, so I'll summarize your question. I hear Micronaut. So what's the difference between Quarkus and Micronaut? 100% of our ecosystem is running on Graal VM. From the very first day, we've been having that in time. What we have in common is this build-time thinking mantra. What we offer is also all of the ecosystem, like CDI and, exporting all of the standards, MicroProfile, and so on. Micronaut tends to have their own APIs to do that. What else? Numbers, just check them for yourself, do your own tests. But for us, it's it's a no-brainer. We really pushed really hard on those numbers. And the live coding is just transformative. So that's a very big difference that none of the other guys really do at the moment. There are more differences, but generally, the Java ecosystem is going the right way with Micronaut and Quarkus. We do think we're better, and I gave you some hints. But check for yourself. Other question? Yes?
How difficult it will be to write an extension for Quarkus?
How difficult is it to write an extension? It's not hard. I was talking to a contributor earlier today, yesterday, well, the time flies. But he's been doing the Panache MongoDB extension. And what he told me is I've been able to explain that to my colleagues, and it's very easy to get started with that. It is harder than just writing your CRUD applications, of course, but we have a very nice model to do the extension framework. And the best is to we got a guide, but the best is to look at an extension that is roughly doing the same stuff you're doing, and look at how they do it and work on that. And what you can do is your extensions can be better and better over time. You might start by saying, okay, I'm just going to do the normal startup at runtime, and then I'll realize, okay, I could read the configuration from the application.property, so I'll improve that, and then I'll maybe be able to move some stuff and do my reflection at build time instead of runtime, so you'll do that. And over time, you've got a maturity model kind of for the extensions. We've had, I don't have the numbers, but we had quite a few net new extensions being provided by people, and we've been learning with them to improve the framework. So it's been 8 months in the making to really fine-tune this. By the way, we're not stopping. We've been doing a release every 9 days, so we might slow down a bit, but every 2-3 weeks for sure. We're going to keep going because we've got a lot of ideas on new features. Now that we know we have a super solid foundation, we'll go really strong on the new feature set. Another question, maybe? I don't see any. Oh, yes. Okay, so if I go for native image, how do I do debugging? That's a good question. First of all of your dev time and classical debugging time will be with the JVM. Okay, so if you find a bug in, even like the vert.x framework or Hibernate or your application, all of that will be dealt with the JVM. if you really have essentially a bug in Grall VM, which leads to a problem that you want to debug with the native image, right now it's a bit tough because you essentially need GDB and off you go. They have quite a few plans. The Grall VM team has plans to really improve that. But for me, in the cloud at least, it's a kind of a false dichotomy because you will deploy, and maybe you will have one instance as JVM and 10 as native until you're really confident about it. Or you will play with the, it's not A/B testing, it's the other one, where you do load balancing between different versions, and you will slowly gain confidence and just go all in native. By the way, we didn't have to debug an actual native image that much. We started in June last year. We had very few cases where we really had to go that way. Last questions, maybe? Yeah.
Is it possible to convert an existing Spring Boot microservice, for instance?
So I'll rephrase your question a tiny bit. Can I take a Spring Boot microservice, do nothing, and make it run on Quarkus? The answer is no. Because the way we see things is more like that's for new microservices, or if it's really a microservice anyway, the rewriting is not that big. And it's really transferring your knowledge. That's why we have the Spring conversion layer, really, okay? But we've seen a lot of people taking code, moving it, adapting it over time. So people having either old Java EE code and moving it around, adapting where it needed adaptation. And they did that in a matter of, it's like a week, couple of weeks of turnovers. And for the Spring side, that's the same sort of model. And we've seen two kinds of users, people that say, OK, I like this Spring approach, and I'll stay with that because my team knows it. And others that were like, let's go all in because it's really a one-on-one conversions. We need to think to the new annotation and style, but it's not that big of a deal. And let's rather move the entire team. And it wasn't slow to actually do those kind of knowledge migration. But again, try it out for yourself and experiment. Thank you very much. Time is up. I'll stay around until Friday. So thank you.